Lagrange's method of calculating maximum and minimum values. This is section 6.8. Suppose you are giving a function f in terms of x, y, z, and it is under the constraint of g, x, y, z equal to k. Now, on that condition, what is the maximum value of f if x, y, z is restricted to this constraint only? Now, if that's the case, Lagrange developed this particular systematic way of hunting down the extreme values. The Lagrange's method doesn't necessarily, what it catches isn't necessarily the extreme value, but any extreme value, if it existed, would be among the stuff that it finds. So the way to do it in the Lagrange's method is you set another function u, define it as the function f plus lambda times g, where lambda is a constant that you're going to find. And then to hunt for the extreme values, you will solve this u here, you will solve partial u, partial x, set it to 0. And same with y and z. And together with the original constraint, which is the equation g, x, y, z equal to some value k. Now, that means you have 4 equations that you have to solve simultaneously for x, y, z, and lambda. So there are 4 variables. Lambda is a constant. The justification of Lagrange's method is based on our previous video, where it says that if a function is constrained to achieve some kind of extreme value, then the proportions of f, the partial derivatives f1, f2, and f3 is going to be proportional to g1, g2, and g3. Okay, so the 3 values have they multiply in a fixed constant. Now, if you take the partial u, partial x right here, if we just do it, then what we get, take partial u, partial x from this equation, we get f1 plus lambda g1. And set it to 0 like this, we equal to 0, which means that lambda equals to f1 over g1. And similarly, doing the same thing, we will also get lambda equals to f2 over g2. And lambda also equal to f3 over g3. As you can see then, that Lagrange's method is trapping that value such that the ratio is exactly the same. And at the same time, the values also satisfy the constraint. And on those conditions, we should be able to find the extreme values if they exist, that is. And out of those, then there might be one that's the maximum or minimum that we're looking for. So that is how the Lagrange theorem is justified. The Lagrange, this one, we have just one constraint in this statement, but Lagrange method works for more than one constraint too. For example, let's say you have 2 constraints. If you have g and then another function h equal to something, if you have 2 constraints, you simply have a lambda 1 times g and then lambda 2 times h, and then you have later, then you have 4 equations. There's g, and then there's another h, which is the 5th equation, and then you have lambda 1, lambda 2, which means you have 5 variables and 5 equations, and you should be able to solve for all 5 and then work it out that way. Now, solving 5 equations, of course, or 4 simultaneous equations is usually not easy, sometimes extremely hard, but it is a systematic way of doing things. And we will do a simple example in the next video.